Hello everyone. Good day. Welcome back to our class in General Chemistry 1. For today's lecture, we'll be discussing the third lesson under our topics in General Chemistry 1. This topic is entitled Atoms, Molecules, and Ions. Without further ado, let's get started in our discussion. Let me share my screen first. Here. So for a discussion overview, I'll be discussing Dalton's atomic theory. So I will explain how the basic laws of matter, the law of conservation of mass, the law of constant composition, and the law of multiple proportion that leads to the formulation of Dalton's atomic theory. And also, I will discuss the difference or the characteristics between atoms, molecules, and ions, as well as the different subatomic particles. So these are the protons, electrons, and neutrons. And then for atomic structure, we will differentiate among atomic number, mass number, and isotopes, and which of these distinguishes one element from another. And then also learn how to write isotopic symbols and recognize common isotopes and their uses. And also we will be having some calculations related to it. So brief history of atoms. So atoms, we know that it composes mostly all of the types of matter. So understanding the sources or structure of atoms is also critical in understanding the properties of matter. So, atoms, though, it comes from the Greek word atomos, which means indivisible. So, um, in another term of indivisible, it means that it is uncuttable, or if you try to make them into smaller, very small pieces, so it cannot be done. So around 440 before Christ, there's a Greek philosopher that is named Leokippos. He originated the atom concept. So according to him, um, he defined the universe now is consists of two different elements. So these different elements, this includes the element of full, or meaning solid, and then an element of empty, meaning void. And then both of these elements, the void and the full, it's composed of infinite and constitute two different elements of everything. So basically, what consists of this universe that he claims, like the full universe and the void universe, they compose of elements of everything, and he refers that as atoms. And then one of his students, named Democritus, he extended his theory or concept. So according to Democritus, he reasoned out that if you cut a lump of matter into very smaller pieces, you would eventually cut it down into a particle that cannot be subdivided anymore. So it will be very small that usually you cannot see it anymore. And then he called this also these particles as atoms. So in both of their concepts, there are five major points. So the first is that all matter is composed of atoms, which are to be seen, too small to be seen, and these atoms cannot be further split into smaller portions. So there will be a time that if you cut a certain thing or a certain matter here into smaller pieces, there will be a time that you cannot further split them into smaller options, and that constitute their concept on atoms. And then atoms also has empty spaces between them. So these empty spaces, they refer this as atomic cloud of a certain atom, and its nucleus is just an empty space, or they are called vacuum. Then also atoms are homogeneous with no internal structure, and they can differ in size, shape, and weight depending on the element or type of matter that they tried to split into smaller portions. And then also, atoms are completely solid. So, the most well-known findings in atomic theory, in studying the atomic theory of matter, is by John Dalton. So, John Dalton, he suggested that all matter was made up of tiny spheres that were able to bounce around with perfect elasticity, and he called this atoms. So usually, Dalton's experiments mostly consist of gases. Yun. So this led to some of his earliest measurements, like atomic masses, um, also the concept of atomic structure, and then also its reactivity. So his ideas, he had he summed it up into three different ideas. So first is that all atoms of a given element are identical. So he claims that in a certain specific element, the atoms there have the same chemical properties, physical properties, they have the same mass, and they also have the same size. So he also claims that the atoms of different elements vary in mass and size. So based on this statement, he claims that the atoms of a different element differs from one another. So while he also claims that all atoms are identical, so meaning different elements had atoms of different types of sizes, also different masses. So next is that atoms are indestructible. So chemical reactions may result in their rearrangement, but not their creation or destruction. So meaning that atoms cannot be subdivided, but they are created, and also they cannot be destroyed. So atoms in different elements, they can combine into simple whole number ratios to form what we call now as chemical compounds. And these compounds are composed of atoms of more than one element. So now we go to the concept of the law of conservations of mass. So basically, the concept is that the concept is based on the John Dalton's atomic theory. So atoms are neither created or destroyed during physical or chemical processes. So in this law of conservation of mass, it simply means that the total mass of a substance present at the end of a chemical process is the same of the mass of those substances present before the chemical processes or the chemical reaction takes place. So we will be looking into the masses of the substances involved. So to illustrate, so here we have atoms of element A. So to understand the law of conservation of mass, the total mass present here is only the total mass of that constitute the element A. So you cannot find other mass here aside from the element A that is mentioned here. and then it reacts now into the atoms of element B. So the total mass here also is the mass of B only, because you cannot see another element here aside from the element B. So they undergo chemical process, then they form a compound. So as you can see, one atom of element A, it combines to two atoms of element B, and then it forms a compound. So the compound composed of elements A and B, and then the total mass also now involves not only A but also B, because two elements already are present in this compound. So here, to illustrate using compounds na given as an example, so we have here 1 mole of methane. So in 1 mole of methane, it consists of 1 carbon atom and 4 hydrogen atoms. So the carbon atom is here and it's bonded with 4 hydrogen atoms, the white ones. And then it reacts with 2 atoms of oxygen gas. So we know that in oxygen gas, we have already 2 moles of atoms. Then to balance the reaction, we need 2 moles of those oxygen atoms. So the total is that we have 4 oxygen atoms in total. And then it formed with carbon dioxide. So we have 1 carbon atom here, this one. And then 2 oxygen atoms is already attached to it. And then also another product is water. 2 compounds of water. So in here we have 4 hydrogen atoms, because each oxygen atom, it combines to 2 hydrogen atoms. So in total, we have 4 hydrogen atoms. But both of them, as you can see, they both consist of 4 oxygen atoms. So here, if you calculate the masses of this compound, so you need to follow the number of individual atoms present in the compound. So if you want to calculate the mass of carbon in CH4, you need to multiply it by 1, because we only have 1 carbon atom. And then if we want to know the mass of hydrogen, is that we also need to multiply it by 4, because we all have 4 hydrogen atoms. Same goes on in the other compounds. So we already defined that atoms are separated here, they combined or rearranged in a certain reaction, but they cannot be created, destroyed, or divided. So as you can see, the atoms are still the same from the beginning of the process, and then after it undergoes chemical reaction, they are also just the same. So na-rearrange lang siya. And then we go to the law of constant proportion. It is also known as the law of definite proportion. So it claims that all samples of the compound have the same composition, the same proportions by mass of a constituent elements. So to further illustrate, we have 1 molecule of water here. So as you can see, we only have 2 atoms present in water, the hydrogen atom and the oxygen atom. So for example, we have 2 samples of this compound or water. And then first we have here in sample A, we have 10 grams of this water. And then in the 10 grams of water, it composed of 1.119 grams of hydrogen. And then the remaining is the mass percent, or I mean the mass of the oxygen. It's not percent, but it's mass of the oxygen. So the total is that we have 10 grams of sample A. So in order for us to calculate the proportion by mass, proportion by mass, or its composition by mass, percent composition by mass. So we need to calculate per element. I mean, per element or per atom. So in percent hydrogen, you need to divide this amount to the total and then multiply it by 100 for us to get its composition by mass, percent composition by mass. So when we do that, we calculated it as 11.19%. So we also do the same for the oxygen. So we have this value here, the 8.881 grams of oxygen. We divide it by 10, multiplied it by 100 so that we could get its mass composition, percent mass composition. And then here, if we want to increase the mass of sample A, for example, we multiply it by 2.7%. I mean 2.7 times. We increase it by 2.7 times the sample A. So when we do that, the total mass of sample B, it becomes 27 grams. And then also, since nag-increase ang mass sa sample B by 2.7 times, so we will also increase the amount of hydrogen and oxygen in the same proportion. So from 1.119 grams of hydrogen, it becomes 3.021 grams hydrogen, and then the remaining is for oxygen, which is 23.979 grams. So the question is, would be the mass percent composition be the same as to the sample A? Of course, it will be the same because they just increase in the same proportions. So if you're confused or if you're not sure that they are just the same, so you can do the same process as we have done in sample A. So this mass here, we divide it by the total, which is 27 now, multiplied it by 100, so it's just the same. So we have still 11.19% of hydrogen in the total sample here. And also for oxygen, we still have 88.81%. So this claims that it states that the chemical compounds are formed and constant. They are defined in the ratios of elements as determined by their mass proportions. So that's the law of constant composition. For the law of multiple composition, if two elements form more than a single compound, the masses of one element combined with the fixed mass of the second are in the ratio of whole numbers. So here we have two compounds given. Excuse me. So we have carbon monoxide. So here in carbon monoxide, we only have one carbon atom, and we also have one oxygen atom. In carbon dioxide, we have two atoms of oxygen combined to one atom of carbon. So in order for us to calculate the ratio of those elements, we need to count the number of atoms present. So here for carbon monoxide, we only have one atom of oxygen and one carbon atom. So the ratio is 1:1, or 1:1. And then for the carbon dioxide, we have two atoms of oxygen, and then we have one atom of carbon. So the ratio is that the ratio in their masses is that it's 2:1 or 2. So to further illustrate, so we have two compounds, sulfur oxide and then sulfur oxide 2. So we have the sample size. We have 2 grams now for the first compound, and then we have 2.5 grams in the second compound. So the mass of sulfur is just the same, but the mass of oxygen is differs by 0.50 grams. So in order for us to calculate the mass of oxygen in the sulfur, in the second compound per gram of sulfur, and then its ratio to the mass of oxygen in the first compound per gram of sulfur, we need to divide the mass of oxygen in the second compound to the first. So it will be 1.50 grams divided by 1 gram. So the ratio on their masses from the two compounds is in terms of mass and oxygen. So in terms of mass and oxygen, it's 3/2 or 3 halves. So this law, it's just very useful to use as a rule in stoichiometry. So it states that compounds will consist of defined ratios of elements also, and then it says that when elements form compounds, their proportions and their elements in their chemical compounds, they can be expressed in whole numbers, in ratios, or also it can also be in fractions. Now we go to the difference between atoms, molecules, and ions. So here we will be defining each term. So for atoms, these are tiny indivisible particles of an element. So as we know that every element has only one type of atom, as claimed in John Dalton's theory. So now in our periodic table, we have 118 elements. So it means that we have 118 types of atoms. Also, atom has neutral charges. So example for this is that we have oxygen, hydrogen, carbon, helium. These are example of atoms. So they don't have they do have neutral charges. For molecules, these are independent structure consisting of two or more atoms chemically bonded together. So atoms in a molecule are held together by covalent bond. So most of them undergoes this type of bonding, and then they also have neutral charges. So example for molecules is that oxygen and water molecule. Also, ions. These are formed when an atom or molecule gains or loses electrons. So most of them have undergo the concept of redox reaction. So I'm sure that most of you have heard redox reaction, right? So it's reduction and oxidation processes. So this process have caused a certain atom or molecule to gain or loses its electrons. And then also, ions can be monoatomic, so meaning they have only one atom, or polyatomic, so two or more atoms. And these ions, they can be positively or negatively charged. So example is that for sodium ion, we have a positive charge, and for hydroxide or OH, we have negative. For hydrogen, H plus, it's positively charged. So to further illustrate, here we have example of atoms, so as I mentioned earlier, and then molecules and ions. So we must remember that all particles are composed of these, all particles can be atom, molecule, or ion. So either of the three. So now we go to the example problem 1. So here we will classify each of the following as atom, atom, molecule, and ions. So for example 1, or A, letter A, helium. So helium, what is it? Yes, it's an atom. For nitrogen gas, N2 gas. Yep, it's a molecule. For this one, yes, it's also a molecule because it's composed of different types of elements. Here, magnesium 2+, Yes, it's an ion, of course. And then oxygen, I mean O2 negative, that's the charge of oxygen. It's also an ion. And then here, PO4. Yes, it's a molecule. You're very bright. Char. And then here we have carbon. Of course, it's an atom. So it's very simple to classify a certain particle as it could be an atom, molecule, or ions. So let's continue. Now we go to the subatomic particles. So atoms consist of these basic particles, the protons, electrons, and neutrons. So for protons, we only bear in mind that these are the positively charged particles, subatomic particles. So for electrons, these are the negatively charged. And then for neutrons, these are the neutral or no charge at all. Here, we look closely to the subatomic particles of carbon atom. So as you can see, here, this is the whole area is the nucleus. So the center part, it contains the protons, which are the positively charged, so the blue ones here, and the neutrons, so the red ones. So ang satunga, it mostly consists of these two. And then the outermost region of the atom, these are called the electron shells. So these shells, they contains the electrons or the negatively charged. So a carbon atom, it consists of 6 protons, 6 electrons, and 6 neutrons. So for a particular number of these protons and electrons, they are fixed as always. But however, the number of neutrons differ in the nucleus. So later, we'll be calculating how to count or how to determine how many neutrons, protons, and electrons are found in a certain atom. So protons and neutrons, they have essentially the same mass. So later I will show. I mean in the next slides I will show it. And then for the electrons, it's so small that we could just ignore it. Here. So as I've mentioned earlier, the number of protons of carbon is 6 and the neutrons is also 6. So its atomic mass is equal to 12. So basically, atomic mass is the sum of the number of protons and neutrons. So you just bear that in mind. For example, if the atomic mass of a certain element is 5 or like that, it's 5. So you could look it up in the periodic table. So what element is that? And then you would know that the number of protons and electrons is, and the sum of them, the sum of it is equal to 5. So that's it. So for subatomic particles, these are the mass of these particles. So as I mentioned earlier, the protons and neutrons have essentially the same mass. So here, look closely. These are the masses of neutrons and protons. So, but they differ in charge. So this is the charge for protons, but there is no charge in neutrons since it's a neutral particle, subatomic particle. And then proton, positive siya, right? It's a positively charged. So the concept is positive, pwede siya 1. It could also be other number, basta positive. Then for neutron, it's 0. Here in electron, as you can see, the mass is very small. So it is also the same charge as for the protons, but negative lang siya. It's negative. Same also, it's in its charge. It's negative. So to remember this pattern, the mass of proton is equal to the mass of the neutron, but it is, both of them is 1,840 times larger than the mass of the electron. So now let's go to the concept of atomic structure. So atomic structure, it states that every different atom has a characteristic number of protons in the nucleus. So to further understand the concept of atomic structure, we will be familiarizing two terms, the atomic number and the mass number of atomic mass. So here for atomic number, it is denoted as capital letter Z. It is equal to the number of protons of an atom in the nucleus. And then we also have the mass number or atomic mass. It is denoted as letter A. It is the sum of the number of protons and neutrons in the nucleus of an atom. So it's not just the protons, but the added to ang number of neutrons. So for example, we have here an elemental representation of carbon. So excuse me. For carbon, the number 12 here, this is the number of protons and neutrons in an atom. While the number 6, this is the atomic number or the number of protons of carbon atom. So if you see a certain element of representation, just like this, just think that the upper number, this is the mass number, while the lower number is the atomic number. Now we also have the concept of isotopes. So these are atoms of the same element that have the different atomic mass numbers due to the different numbers of neutrons. So they differ lang sila in their mass number, but they have the same atomic number because of the number of neutrons. In these isotopes, they have fixed number of protons because it is based on their atomic number. So here to summarize, also mass number is also equal to the atomic number plus the number of neutrons. It's understandable because the atomic number is just equal to the number of protons. Here to further represent the elemental representation. And then as I've said earlier, isotopes, these are atoms of the same element. So they just differ in their numbers, in their mass number due to the neutrons in their nucleus. So here we have isotopes of hydrogen. So as you can see, we know that hydrogen has an atomic number of 1. But in this example, we have 3 different isotopes of element hydrogen. So this one here, this is pure hydrogen. This one here is hydrogen. This one here, they have a different mass number. So this is because is termed as deuterium. This is another isotope for hydrogen. And then here, if we have additional two numbers of neutrons in the nucleus of the hydrogen atom, this is termed as tissue. So to further understand the concept, so for hydrogen 1, we have 1 proton, this red one. And then we have, for hydrogen 2, we have 1 neutron, additional 1 neutron. And then also for hydrogen 2, we have 2 neutrons here. But both of them have the same atomic number. Now we go to percentage abundance. So this is the relative abundance of an isotope. This is the percentage of atoms with a specific atomic mass found in a naturally occurring sample of an element. So here we have different isotopes of elements or atoms. given na ang natural abundance or percent abundance. So the percent abundance here is, this is experimentally determined. And then also stated here are the number of protons and neutrons and their atomic masses. So we will be understanding percent abundance in a sample problems. Here, so this is the sample problem that I'm referring to. So given the three isotopes of oxygen with its corresponding atomic masses and percentage abundance, calculate the average atomic mass of oxygen, which is 15.99 atomic mass unit, or 16, on the periodic table. So how will we do this? So first thing we need to do is to write the formula. So for mass, wait, there's something wrong with my pen. For mass, mass is equal to, mass number of an atom is equal to the atomic mass unit of a certain isotope, of an isotope, multiplied by its percentage abundance. So since we are given here 3 isotopes for oxygen, so we'll be using all of this. So here we have for oxygen 16, it's 1599.15 atomic mass unit. Then we multiplied it by 0.99762 as its percentage abundance. And then we add the values for oxygen 17. So we have 16.99131 atomic mass unit multiplied by 0.003. Sorry, so this is 0.003. This is 0.00038 because it's divided by 100. And then I'm just using my calculator so that I will not be mistaken in converting the percentages. So multiplied it by 0.002. So we have used the atomic mass and the percent abundance of the isotope. So to calculate this one, use your calculator. The value would be 15.999 AMU. See, we have arrived to the mass number of the oxygen atom in the same into the periodic table. So if you're given isotopes and then atomic masses and its percent abundance, and then you're asked to calculate the mass number, so you just need to do this process. So another example is that given the 3 isotopes of oxygen with its corresponding atomic masses, how many numbers of protons, electrons, and neutrons present in each isotope? So here we only have atomic masses. So in these 3 isotopes, we are asked to calculate the number of protons, electrons, and neutrons. So how do we do that? First is that we need to write also the formula. So since we are given the atomic mass, so we write the formula again. Atomic mass number is equal to the kabalumata na atomic mass number is equal to the number of protons plus number of neutrons. So which is also equal, since the number of protons is equal to the atomic number. So it's also written as the atomic number plus the number of neutrons. Here, so For oxygen 16, since we wanted to know its number of protons and protons and neutrons, so we just use its atomic mass, which is 15.99415 atomic mass unit. So using the formula, we know that the atomic number of oxygen is 8, right? So the missing value will be the number of neutrons. So we just subtract 15.99415 by 8, so we could get the number of neutrons. So 15.99415 minus 8. So we have a 7.99415 neutrons, rounded off, which is equivalent to 8. But you could also express this as in this value and also in this. For oxygen, sorry, I just noticed this is oxygen 16, this is oxygen 17, not 16, and this is oxygen 18. Sorry. So for oxygen 17, the atomic, we do the same process, 16.999131 AMU as its atomic mass. Then we have known the number of protons as 8. So we will calculate its number of neutrons. So same procedure, we could calculate it as 8.99131 or 9 number of neutrons. As you can see, they differ by one atom. They differ in one number of neutrons. So they have the same atomic number. They are both oxygen, but they differ in their neutrons. So to get the number of neutrons, so let's do the same process. Just make sure to calculate it. So here we have additional 2 number of neutrons, since the number of neutrons here in oxygen 18 is there's an additional 1, so it becomes 10 in its number of neutrons. So these are the number of neutrons of the 3 isotopes. So the number of protons is just equal to 8. So I guess that's clear. So for your practice problems, I hope that you will do this. So I've given you 3. The first one is that what would be the symbol for an element which has 14 protons and 15 neutrons? And then how many protons, neutrons, and electrons are in this iron 3+ ion? And then use this data to calculate the atomic mass of neon. So since you know naman how to classify atoms, molecules, and ions, so I don't add any process problems related to it here. But I hope that you really understood how to differentiate the 3. So that would be all for this lesson. So I hope that you learn a lot. And if you have questions related to our discussion today, just email me, and then let's discuss it together. And I hope that this could really help for you. So thank you for listening, and I hope to see you on the next lesson. So, thank you everyone, and have a great day.